Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is Lesson 25, Geometric Interpretation of the Solutions of a Linear System. Okay, classwork exploratory challenge. Do not ask me if you have to do exploratory challenges. Without challenge, we do not grow. Yes, you have to do exploratory challenges, so let's do this. Number 1, sketch the graphs of the linear system on a coordinate plane. This is in standard form. If I just rearrange the x and the y, ax plus by equals c. So it's kind of in standard form if all I have to do is switch the x's and the y's. Everything is on the same side of the equal sign, so my a is 1 and my b is 2 and my c is 12. This is in the form y equals mx plus b, which is slope-intercept form. It is much easier to graph a standard form equation using intercepts, and it's much easier to graph a slope-intercept form using the y-intercept and the slope. So we're going to do this two different ways. So I'm going to find this one here I'm going to do with intercept. So if I want the x-intercept, I know that y equals 0. And if I want the y-intercept, I know x equals 0. So I will write this equation twice. 2y plus x equals 12. 2y plus x equals 12. Substitute in 0 for y, and I get 2 times 0 plus x equals 12. This is 0 plus x equals 12, so therefore x equals 12. Well, x equaled 12 when y was 0, so there's my point, 12, 0. That is right here. Now I'm going to do it again, but this time I'm going to make x 0. So I get 2y plus 0 equals 12, or 2y equals 12. Divide both sides by 2, and I get y equals 6. So I have 0 when x is 0, y is 6. So that's the point 0, comma 6, which is right here. I only need 2 points to graph a line, so I'm going to go get my ruler now. Bring it down here, and be really careful and accurate. Accuracy is super important here because we are trying to find something, and I'm going to explain that when we get to that point. So please be as accurate as possible. Do not just sketch a line and it's all squiggly because you didn't use a ruler. Okay, so right about there, and I'm going to draw my line. So there's my line, and I'm going to label it. So I'm going to write 2y plus x. 2y plus x equals 12. Okay, now I'm going to graph this line using slope-intercept form. So if I have y equals 5 over 6 x minus 2, my slope, or m, is 5 over 6. My b, my y-intercept, is negative 2. So we always plot our b first. It's right here at negative 2. Y-intercept, negative 2. The slope, or the rate of change, tells us that y is changing by 5 and x is changing by 6, which means I want to go up 5 on the y-axis and over 6 on the x-axis, and I'm landing right there. I'm going to put my ruler here, rotate it, make sure it's nice and accurate, draw a line through, and now I'm going to label this as y equals 5 over 6 x minus 2. The point of intersection is right there. That is the point 6, comma 3. So here it says name the ordered pair where the graphs of the two linear equations intersect, and it is the point 6, comma 3. Verify that the ordered pair named in part A is a solution to this. So all they're saying is this is x, this is y, substituted into here. So I'm going to write 2, and instead of y, the value of y is 3, plus, instead of x, the value of x is 6, equals 12. 2 times 3 is 6. 6 plus 6 is 12. equals 12, and 12 definitely equals 12. So that is a verification. This is true, so that point is on that line. Now they're asking us to do the same with this equation. So if I have y equals 5, 6x minus 2, and y is 3, then I'll substitute in 3 for y. 5, 6 comes down. X is now 6. So I'm going to multiply by 6. Think of that as 6 over 1, and then subtract 2. So if I cancel the 6's, I get 3 equals 5 minus 2. And when I simplify, I get 3 equals 3. So there's a verification that it made both equations true because it's right there on both lines at the point of intersection. D says to check to see if the points 4, 4 would be a solution to this system. In order for a point to be a solution to a system, it's got to make both equations true. And that's what it says. That is, would it make 4, 4? Would 4, 4 make both equations true, y or y not? So if I do that again, and I take 2y plus x equals 12, and take the other equation, which was y equals 5 6 x minus 2, I'm verifying that from memory, 5 6 x minus 2. What they're asking is, does this x, y make these equations true? So if I plug in x and y is 4, in other words, 2 times 4 plus 4 equals 12. 2 times 4 is 8, plus 4 equals 12. 12 equals 12. That's true. So it made this equation true, which means it would land on that line, 2y plus x equals 12. Now if I go back and graph it, and I go over 4 up 4, it does indeed land on that green line. That is the point 4, 4. Okay, now when I plug in 4 here, I get 5 over 6 times 4 over 1 equals, or not equals, minus 2. This 4 will reduce to 2. This 6 will reduce to 3. So I get 4 equals 5 times 2 over 3 minus 2, which is 6/3. And therefore 4 equals 10 minus 6 is 4/3. Obviously 4 does not equal 4/3, so it is not a solution. And when we look at the graph, it's obvious that it is not on the blue line. Okay, so hopefully you're getting an idea of what this lesson is trying to point out here. Systems of equations, the point that they give us, or our intersection point, the x and the y will make both equations true, and there will only be one unique solution. So now we're going to keep checking that and finding these solutions so we can solidify our understanding. So now again, we have standard form. So I'm going to do x-intercept, y-intercept, and then we have slope-intercept form. So I'm just going to simply do y equals 4x plus 3 and state that my slope is 4 over 1, show it as a ratio, and my b equals 3, that's my y-intercept. Okay, so getting back to the standard form requires a little bit more work, but it's not bad. We let y equal 0 when we're looking for the x-intercept. We let x equals 0 when looking for the y. So I'm going to write x plus y equals -2 twice, and plug my y in for 0 here, so I get x plus 0 equals -2. Therefore, x equals -2. That means that when x is -2, y is 0. If I plug 0 in for x this time, then I get 0 plus y equals -2, and y equals -2. So therefore, I have the point 0, -2. Plotting those 2 points, I get -2, 0 is here, and 0, -2 is here. Grab my ruler. I wish this program would drop it where I'm working instead of at the top of the page, but that's what they do. Alright, so I'm going to bring this over, and I'm going to put the ruler right there, rotate it, try to be as accurate as possible, and draw a line. I'm going to label my line, okay, and the equation is x plus y equals -2. So there's that one line. Now I'm going to do the same for the red, or the y equals 4x plus 3 in red. And again, when we're plotting slope-intercept, we plot the y-intercept first, which is 3. That means it's the point 0, comma 3. So I'm going to put a dot at the point 0, 3. My slope is 4 over 1. That means y changes by a value of 4 and x is changing by 1. So I go up 1, 2, 3, 4 and over 1. Put a dot there. And then I'm going to connect those dots and we will find where these two lines intersect. Okay. And that looks pretty good right there. We're off a smidgen, but we'll see where that's crossing. So my point of intersection, now it says name the ordered pair where the two lines intersect. It is actually right here. I was off a little with my ruler, but it's -1, -1. Okay, now it says to verify that the ordered pair makes this true. So is this a solution? Is -1, -1 a solution to this equation? Well, let's see if it's true. So instead of writing x, I'm going to write -1. Instead of writing y, I'm going to substitute in -1. -1 plus -1 is -2. -2 absolutely equals -2, so that is true. So that means it is on the black line here. Now C is asking to verify that the ordered pair -1, comma -1 is a solution to this. So my y goes here, -1. This is x, it goes here, plus 3. So -1 equals -4 plus 3. -1 equals -1, and that is also true. So that means it is on the red line, and obviously it's right there. Now it says it's asking if this point could be a solution to the equation, -4, comma 2. All right, so I'm going to plot that point. -4, 2 is right here. I'm on the black line, but I'm not on the red line, so I would say right there that no, it is not a solution. And I did not label this y equals 4x plus 3. Okay, so this is a solution to x plus y equals -2, but it is not a solution to 4x plus 3. And I could check that, and I will check that. So I need to write those two equations again. So that is x plus y equals -2. Let me keep the same colors. So I did that line in black before. X plus y equals -2. And the other line is y equals 4x plus 3. And I did that in red. Y equals 4x plus 3. Now substituting in -4, 2 into this, I would get x is -4, y is 2, and check to see if this is true. And -4 plus 2 is -2, and -2 equals -2. Now I'm going to check it with this. Y is 2. Bring down the 4. X is -4. So we're going to multiply 4 by -4 and add 3. So 2 equals -16 plus 3. So therefore 2 equals -13. No, it doesn't. Therefore it's not a solution. So that point should not be on the red line. But since it made this true, it should be on the black line. So if I go back and look, sure enough, that blue point is on the black line, but not on the red. Okay, so one more time. Problem 3. This is standard form. X intercept, y intercept. When we're looking for the x-intercept, y is 0. When we're looking for the y-intercept, x equals 0. Write the equation twice. And substitute in your y, substitute in your x. So this will be 3x plus 0 equals -3. 3x equals negative 3, divide by 3, divide by 3, x equals negative 1. Negative 1 comma 0 is the point, and it is right here. Substituting in 0 for x, I get 3 times 0 plus y equals negative 3, and 0 plus y equals negative 3, and therefore y equals negative 3 when x is 0. So there's my point, 0, negative 3. Get my ruler. It's easier to do this, for me anyway, if I just put the 0 right there. Draw my line. This is the equation, 3x plus y equals negative 3. All right. All right, so now I'm going to do the same for this one. It's also in slope-intercept form, so I'm going to do the same thing. I want the x-intercept and the y-intercept. Therefore, y equals 0 here, and x equals 0 here, and I'm going to plug in negative, I'm going to write the equation negative 2x plus y equals 2 twice. I will substitute in the 0 for y, I will substitute in the 0 for x. So I get negative 2x plus 0 equals 2. Negative 2x equals 2. Divide by negative 2, and I get x equals negative 1. So I go over to negative 1, 0, and put a dot right there. Then I plug in 0 for y, so I get negative 2 times 0 plus y equals 2. 0 plus y equals 2. Y equals 2 when x is 0. The point 0,2 is right here. I'm going to put my ruler right on the one solution, rotate it around. Be careful to be accurate. Draw a straight line with your ruler and label your equation. Negative 2x plus y equals 2. I'm going to mark the intersection in black, and that is the point negative 1 comma 0. So that's the ordered pair where they intersect, negative 1 comma 0, and now they will probably want us to prove it by substitution. So I have the point negative 1, 0. So I'm going to write that here. Negative 1 comma 0 is my point. I want to verify that it's true in both equations, and I did the negative 3x in red and the other one in blue, so I'm going to keep this color coded. So negative 1, 0 is 3 times negative 1 plus y is 0 equals negative 3. Negative 3 plus 0 equals negative 3. Negative 3 definitely equals negative 3, so that is a solution to that equation. Plugging in negative 1 comma 0 to this equation, I get negative 2 times negative 1 plus y equals 2. 2 plus 0 equals 2, and 2 definitely equals 2. That also checks. Now it says, could the point 4, 1 be a solution to this system? That is, would 1, 4 make both equations true? So let's check. So if I do 3x plus y equals negative 3 and negative 2x plus y equals 2, and substitute in this x and this y into both, I get 3 times 1 plus 4 equals negative 3. 3 plus 4 equals negative 3. 7 equals negative 3. No, it doesn't. Plugging in 1, 4 here, I get negative 2 times 1 plus 4 equals 2. Negative 2 plus 4 equals 2. 2 equals 2. That checks. So the point 1, 4 is on my blue line, but not on my red. So if I go back and plot it, go over 1, up 4. So if I go over 1, up 1, 2, 3, 4, I am right here. This is the point 1 comma 4. It made negative 2x plus y equals 2 true, but the 3x plus y equals negative 3 was false. Therefore, it is on one line, but not the other. Okay. Okay, number 4, it says to sketch the graphs of the linear system on a coordinate plane. Standard form, standard form. So x intercept, y intercept. When we're looking for the x-intercept, we make y 0. When we're looking for the x or the y-intercept, we make x 0. Okay, so I'm going to write 2x minus 3y equals 18. 2x minus 3y equals 18. Since these are both in standard form, this time I am going to just make a line like this because now I need to solve. I'll do this one in red and I'll do this one in green. I need to do the same thing for both. So over here I'm going to write 2x plus y equals 2. 2x plus y equals 2. So we're going to do the intercepts for both of these since they're both standard form. So plugging 0 in for y, I get 2x minus 3 times 0 equals 18. 2x minus 0, 3 times 0 equals 18, or 2x equals 18. Divide both sides by 2, and x equals 9. So that is the point 9, comma 0. So I go over to 9 and plot it. Do the same here, and plugging in 0 for x, I get 2 times 0 minus 3y equals 18. 2 times 0 is 0, minus 3y equals 18. Negative 3y equals 18, divide by negative 3, and y equals negative 6 when x is 0. So that is 0, comma negative 6, which is right here. Grab my ruler, bring it over, and draw my line. Okay, so there's my equation. Label it, 2x minus 3y equals 18. Okay, now I'm going to do the next one in green. Same scenario, plugging in y, I'm going to get 0, plugging 0 in for y, I should say. That's what I'd get. 2x plus 0 equals 2, 2x equals 2, divide by 2, and x equals 1. That is the point 1, comma 0. Plotting that, I go over 1, up 0 is right there. Plugging 0 in for x this time, I get 2 times 0 plus y equals 2. 0 plus y equals 2, or simply y equals 2 when x is 0. So I'm at the point over 0, up 2. So there's my point, my 2 points. And bring my ruler around and draw a nice straight line with the ruler. And this is the equation 2x plus y equals 2. Okay, I'm interested in where they intersect. That is right here. That is the point 3, comma negative 4. Name the ordered pair 3, comma negative 4. Okay, I'm going to go a little quicker now because we've done this many times. This is my x, this is my y, and they now want us to verify this point makes these two equations true. 2 times my x minus 3 times my y should equal 18. 6, negative times negative is positive. 4 times 3 is 12. 6 plus 12 is 18. 18 equals 18. That verifies they are true. Do the same here. 2 times 3 plus a negative 4 equals 2. 6 minus 4 equals 2. 2 equals 2. It is true for both. Could the point 3, 1 be a solution? I'm just going to do this one way this time since I've done it many times. 3, and what point did they ask for? could the point 3 comma negative 1 be a solution? So if I go over 3 down 1, actually I'm going to do this because this is a different scenario. This point is right here. This is the point 3 comma negative 1. It is not on the green line. It is not on the red line. So it should make both equations false. So I'm going to verify that for you. So I'm going to write those two equations. 2x minus 3y equals 18 and 2x plus y equals 2. Substituting in 3, negative 1, I get 2 times 3 minus 3 times negative 1 equals 18. 6 plus 3 equals 18. 9 equals 18. No, it doesn't. Plug in 3 for x. Plug in negative 1 for y. 6 minus 1 equals 2. 5 equals 2. No, it doesn't. So therefore, we just verified that that point doesn't make either equation true. So therefore, that point is not on either line. Okay. Number 5. These are both slope-intercept form. So I'm going to do y equals negative x. Oh, y, no, it's not. I take that back. The first one's point is standard form reversed. That would be the same as negative x plus y. So I'm going to do the standard form rule with that, which is y-intercept. In other words, x equals 0. And x-intercept. In other words, y equals 0. So I'm going to write y minus x equals 3 twice. Substitute in 0 for my x, so y minus 0 equals 3. Therefore, y equals 3 when x is 0. Substitute in 0 for y, and I get 0 minus x equals 3. Be careful with your negative sign. 0 minus x is a negative x. And if I divide by negative 1 on both sides, then I get a positive x equals a negative 3, and that is the point. Sorry for that interruption. The bells are off. Okay, so anyway, x equals negative 3, and that therefore would be the point negative 3 comma 0. Okay, so now I'm going to plot these points. 0, 3 means over 0, up 3. Negative 3, 0 means left 3, up 0. There are my 2 points. And go get my ruler. Way up here. Okay. Bring this down. And there is my line. And that is the line. Actually, let's not go out so far. I need that to work. Y equals, or not y equals, y minus x equals 3. Okay, I'll do the next one in green. And it's y equals negative 4x minus 2. My slope is negative 4. Make it a fraction or a rational number. And b equals negative 2, which is my y-intercept, which means the point 0 comma negative 2, which is right here. That's my y-intercept. And then my slope is negative 4, 1. That means to go down 4 and right 1. Okay. Drawing a line through these points will give me this line right here. Okay, and that is the line negative y equals negative 4x minus 2. Okay, kind of tough to write at an angle with this thing. So there it is. There's our equation. Where did they intersect? Right here. What point is that? Negative 1, positive 2. Name the ordered pair. Negative 1, comma 2. Verify that that's true. Y is 2 minus a negative 1 equals 3. 2 plus 1 equals 3. 3 equals 3. There, I verified. Negative 4 times x, which is negative 1, minus 2 equals my y, which is 2. So I get 2 equals 4 minus 2. 2 equals 2. I verified. Is the point negative 2, 6 a solution? Negative 2 up 6 is right here. I am on the green line. I'm not on the red, so it'll make the green true and the red false. Okay? So the answer is no. And to verify that, I'd say y minus x equals 3, and y minus 4x minus y equals 4x minus 2. Negative 4x minus 2. Substitute in the point negative 2, 6. So y is 6 minus a negative 2 equals 3. 6 plus 2 is 8 equals 3. No, it doesn't. Plug in y. 6 equals a negative 4 times a negative 2 minus 2. 6 equals 8 minus 2. 6 equals 6. That is true. So it made one true and not the other. So it is on one line, the green one, but it's not on the other. The y equals, or the y minus x equals 3 was false. Okay, now it says to write two different systems of equations with 1 comma negative 2 as the solution. Okay, to write two different systems of equations as this solution, keep in mind that this is an x and this is a y. So if I just simply said x plus y equals negative 1, that is definitely true, because if I plug in 1 plus a negative 2, that's negative 1. So x plus y equals negative 1. So if I'm doing a system, it's going to look like this. So there's one in standard form. And I've had a little more experience with this, so it might be a little easier for me, but we could also do graph it and do slope intercept. So if I did that, plot a point 1, negative 2, and plot this equation. So that's another way of doing this. But I can also just come up with a value, an equation that would make both of these true. So how else could I do this? If I said, let's see, y, which is negative 2. I'm trying to make one standard and one slope intercept. So if I say y equals, then that's negative 2. So I'm just going to do this over on the side. If I have y equals mx plus b, and I know my y is negative 2, and my x is 1, so what can I do with m and b to make that true? Well, if I just pick a value for b, how about 3? And so now I have y equals m times 1 plus 3. So I want to know what m would be, so I subtract 3 from both sides, and I get negative 5 equals m times 1, or just m. So if I have negative 5x plus 3. So if I plug in 1, I get 1. If I plug in negative 2 here, I get 10 plus 3 is 13. That is not true. What did I do wrong? So this is what's going to happen. We're going to have to use trial and error, but, be persistent. Try to figure this out. So if I want y, oh, that's where I went wrong. I made y 1, not x. If y is negative 2 and x is 1, or did I do that? Then what is my linear equation going to be? So I have an m let's see, where was I? Okay, so if I make y negative 2 and x1 like this, I need to come up with an equation that would be true. So let's just make b 3. Let's try this again. I'm doing something wrong and I've got to figure it out. So if y equals mx plus b, and I know my y is negative 2 and my x is 1, I need to find a value for m that would make this true. And so I have negative 2 equals m plus 3, and if I subtract 3, I get negative 5 equals m. So I get y equals negative 5x plus 3. So if I plug in 1 for x, I get negative 5 plus 3 is negative 2. Okay, there it is. That is one system. Okay, so now it says write 2, so hopefully you're getting a feel for this. So how about 2x plus y equals, now this first one's easy. Whatever you make up, then you just substitute in and find the number. So if I plug in 1 for 2, that's 2. And if I plug in negative 2 here, 2 minus 2 is 0. So 2x plus y equals 0 is an equation. Now if I do a linear equation, just let y equal something, and I come over here and say y equals mx plus b, and I have an x and a y. Negative 2 equals m times negative 2 plus b. Just choose a value for b. So subtract 4 from both sides to solve for m. And I get negative 6 equals negative 2m. Divide by negative 2, divide by negative 2. I'm thinking of the answer and writing it. And m equals positive 3. So I get the equation y equals 3x plus 4. So I'm going to check that again. So 3 times 1 is 3, minus 8, or 3 times 1 is 3, plus 4 is not negative 2. So what did I do? So this is a little tricky. 2x plus y equals 0. 2 plus y is 0. That's true. Y equals mx plus b. I chose my y to be negative 2, and there's my error. My x is 1, so this should be a 1. Alright, so that should be a 1. So y equals mx plus b. Y is negative 2. M times x, and I chose 4 this time. Subtract 4, subtract 4, negative 6 equals m. So my slope is negative 6 plus 4. So if I plug in 1, I get negative 6. If I plug in negative 2, so 1 times negative 6 is negative 6, plus 4 is negative 2, and that is true. So there are 2 systems of equations that have this solution. Whew. Okay, that is the end of lesson 25. Review the lesson summary and go do your problem set.